So it took the patrol boat 5 hours total to travel 60 kilometers up a river against the current, and then 3 hours to make the return trip back with the current. Find the speed of the boat in still water. So what would that be? We're trying to find the speed of the boat and the speed of the current. So those are the two unknown variables. So let's pick variables for that. Let's say B. B represent the boat speed. And let what? C represent the current speed. Okay, so in this question, you're looking at distance, speed, and time. So we need to figure out the formula, right? We have to come up with two equations. What are we given? What are we given the total of altogether? The speed, the time, or the distance? We're given the distance. We know what the total distance is. So we know our equations are going to be equal to what? What is the total distance? 60. Does that make sense so far? How do you calculate distance? What do you take? Speed and time, what do you do with them? Speed times time, or we could write time times speed, right? Let me write it the other way. Oops. Time multiplied by speed will give us the distance. Same for the second equation. Time multiplied by the speed gives us the distance. We know that there's two methods of traveling. One is against a current and one is with a current. If you're going against the current, think about it. Is it going to take you longer to get there or quicker? Longer. So let's say that this one will be against the current. And this one is with the current, so it's quicker. Right? So what was the time it took against the current? How long did it take the boat to go against the current? What was the time? 5, right? What was the time with the current? 3 hours. Do you see that? It took the boat 5 hours to go against the current, and then 3 hours to make the return trip with the current. I need to take time, and I need to multiply it by the speed, but the speed is affected by the current. Okay, so the speed is represented by the boat speed and the current speed. We don't know what the boat speed is, and we don't know what the current speed is, but that will give us the speed of the boat altogether, right? If it's taking you longer, so if you're going against the current, it's taking you longer to get there. Would you take the speed of the boat and would you add the current to it, or would you subtract the current? You're not going to add it because then your speed would increase, but your speed is actually slower. So you would take the speed of the boat and you would take away and you would subtract the current because your speed is slower. This has a slower speed because you're going against the current, right? This one has a faster speed, so we would take the speed of the boat and we would add the current. Your speed is going to be greater if you're going with the current. So we have our two equations. Our first equation, let's expand it. What's 5 bracket B minus C? How could I expand that? This would be equal to 5B minus 5C equals 60. And what's the second equation equal to? What's 3 times B? 3B plus 3C equals 60. These are our two equations. Equation 1, equation 2. It's a linear system. How do I solve this? Okay, so we're going to solve this by elimination. I need to eliminate one of the variables, but in order to eliminate the variable, I have to make the coefficients the same. So, what do you want to change the coefficients of, B or C? It doesn't even matter. Sure, it doesn't matter. So what are we going to multiply the first equation by? Multiply it by 3, which will give us 15. So I have to multiply this equation by 5. So let's rewrite it. I have 5 times 3 is 15b minus 15c equals 60 times 3, 180. And then 3, that would be 15b plus 15c equals 60 times 5 is 300. And because, look here for a sec, because these are both positive, so I'm going to choose to eliminate my b's, okay? I have to subtract to get this to be 0. So I have to subtract everything. I have to subtract positive 180, take away 300. What does that equal to? Negative 120. And then watch your signs here. Look here. Negative 15, take away 15 is not 0. What's negative 15, take away 15? Negative 30C, right? Elimination, divide by negative 30, divide by negative 30, C equals 4. 4 kilometers. And what did C represent? The speed of the current. Yep. So the speed of the current is 4 kilometers. What's the speed of the boat? We have to find out what B is equal to. You can go back to one of your original equations. Let's just do the first one. 5B minus 5, we solved for C, so let's plug it in, equals 60. So 5B equals 60 minus 20. Sorry, my bad. Thank you. It's plus 20. 80, divide by 5, divide by 5. What's B equal to? 16 kilometers. So the speed of the boat would be 16 kilometers. So let's go back to our 2 original equations. Okay, these were our 2 original equations. And remember, it was time multiplied by speed. Well, what's the speed for the first part of the trip? It was 16 minus 4, right? So what's the speed of the first part of the trip? What's 16 take away 4? 12. So in the first part of the trip, the boat was traveling at a speed of 12 kilometers per hour. And in the second part of the trip, instead of subtracting them, we're adding them. 16 plus 4 will give us a distance. 16 plus 4 is 20. So times 20. So the speed was 20 kilometers per hour. It was going way faster. That's why it got there quicker. It got there in 3 hours. The first part, it took 5 hours to get there. But it traveled the same distance, right? Does that make sense in real life?